Well, thank you, everybody, for being here. Thank you, Stefan Behnisch, for coming so long. We are so glad. Thank you, Lara. I wanted to thank you also, give a special thank you to our sponsors, Siemens Moulins, Propamsa, Neocerámica, and Simon Arc, and our host, ESE, of course, thanks to whom we are being able to enjoy this ambitious lineup with the presence of international speakers who bring us their personality and the profession. I mean, this is very important. It's important to see them, to almost touch them, and that allow them to explain us their work. Well, it was the time to talk to Javier. We are happy that they came to welcome us. No, we wanted to have them the first day, but it was very hard for them, also for the organization, and we have them today. As you know, we are in the fourth session of Foro. It's focused on technology, low tech versus high tech. And as you know, we are seeing proposals of landing of the profession. No? After several years of global, socioeconomic changes, such as climate change, that we can see with the pacification of the cities, greater respect of nature. Also, the wars close to Europe has caused many changes, changes on the price of electricity, of the building materials, and all of them have caused the need for social, political, economical, and energy-saving changes, and therefore direct consequence in how we should think and make architecture. That's why we are glad to bring with us architects that has a long career, that has a long experience, and that has they have been working on architecture for many time, and they have succeeded. So they are examples that we should take very in deep, and understand them, okay? Now, from observing Stefan Behnisch architecture, I would like to emphasize its humanistic side. For each, Can I go forward? Yes, I'm sorry. No high-tech and low-tech solution, but I want to emphasize his humanistic side. I will explain it later, but as I learned from him, he started studying philosophy and scientific economics, but then he realized that he wanted to study architecture, to be an architect. So he says that every project that he does, he starts from the full understanding of the client and the community that will use the architectural spaces, considering the human experience as the core of the project. We have seen that. We have seen some of your students that the projects that Stefan is doing, or they are doing, they are very focused on the movement of the people, on the knowledge, on the meeting points. We will see later, and I'm sure with the presentation that he will do. The project of his studio, under the humanistic vision of architecture, provide low-tech solution with high-tech features. I found a text which I will be very interesting to point it out, because it was somehow merging this humanistic point of view and the architecture that he does. It's an article called New Directions in Sustainable Design Practices, written by John Reynolds from Miami University, entitled Behnisch Architekten, New Directions in Democratic and Social Responsible Sustainable Design Practices. In this article, Stefan comments that, it's a bit long, but I think it deserves to talk about it. In short, it can be stated that the dwellers or the users of the buildings we design are also challenged. In particular, they should learn that a low-energy building or an ecological sensitive building requires a certain behavior and also certain restrictions, which seems to challenge the much emphasized comfort. A new definition of comfort has to be found and disseminated. This is essential a political process which is hardly within the influence of the planners and should be promoted by opinion leaders. It puts the emphasis on the user, we can be as an architect very good and doing very well projects, but the users should be part of this, not only as a passive element, but as an active ones. Other important words from Reynolds and the conversation with Stefan is that respecting building users, involving them within the building democratically conceived social fabric, gently empowers them to adopt positive, environmentally friendly practices in their workplace, environment, rituals, and daily activities. So how important is to understand all the effort that we do as an architect to do good buildings, to do buildings that are related with the nature, with so many aspects that we already have seen in other talks, and we will see in Stefan's presentation. This statement takes me back to a recent article I read by Xavier Monteis, an architect and professor at ETSAP, on beam benders and la arquitectura malalta. Translator is beam benders and the sick architecture. So allow me to bring you a little fun, pragmatic example. In the article, he links a building that is considered to be sick and recently released film, and the recent film by Wim Wenders called Perfect Days. The sick building seems to be not caused of the architectural object itself. It's sick. It's realized under concepts of bioclimatic architecture and low CO2 impact materials, but it's sick because of the inadequate use that it has been given during its lifetime. So sometimes buildings doesn't work only because architects' faults, but also maybe because the users didn't understand how to use it. So this is the fun element, no? Beam Bender's film is shot with a great sensitivity towards architecture. He was asked to make a documentary about the Tokyo Toilets project, a set of 17 high-tech public toilets commissioned from renowned architects and designers, scattered through Tokyo's public parks and gardens. You will say, how come, no? But I will explain it. So Benders tries to humanize the gaze and look and do a movie with focus on the person in charge of cleaning these toilets, no? A low-tech cleaning, how he takes care of what is part of his life and what is part of his job. Even if it's cleaning public toilets, he considers as important where he lives as where he works. So these are images, no? He's cleaning the plants very carefully with his hands. He's just living watching how the day is, no? Before going to work. He's at home, he's taking his clothes, no? But in a very low-tech atmosphere, no? With a very slow light and wood and material, no? It's another scale. And how he goes to clean these very technological toilets that are dissipated in Tokyo, no? And how he's just enjoying this, the life and the work, no? Everything. So I put the reality, no? This has been a high-tech Tokyo toilet as an example. There are 17, and this is made by Shigeru Ban. It is in the middle of a park, and the gas walls become opaque, no? When you enter in, and easily to check who is inside, no? So this is one of the toilets. I will say this is high-tech, no? And then how the cleaning becomes high-tech, no? It is very sophisticated cleaning. So who are taking care of this? Then the low-tech Tokyo toilet is a low-tech made with our technology. No, it's not just a low-tech that has been done in a country that they have no other tools to do it, no? But in this case, no, the toilet, it's more in relation with the prehistoric Japanese architecture. So there is no almost high technology. It's made of walls, of course, there's some technology, and natural light, no? So it's somehow a contradictory position of the previous one. And then how the cleaning becomes kind of low-tech cleaning, no? They understand how to clean and how they teach the child how to clean, something like that. This is Japan, it's another wall, but why not do? So, and also, well, within that particularity of the building is their utility, their function, and consequently the relationship between people, building is functional, utilitarian, and rational. It's very cold. In Bender's film, the relationship between the user and the architectural object, it's very nuanced, and shows another way, a different relationship between people and buildings, not as a mere user, but as a caretakers. It's not about using the buildings, but rather about making them work, understanding them, cleaning them, taking care of them, establishing a relationship with them more similar to the one we have with plants, with living beings. So to sum up, was this like kind of paradigm shift. The building, the architecture takes care of the humans. We have always seen that. The low-tech, it's more familiar to humans. It's embedded in our nature. The high-tech allows the low-tech of a building to be more efficient, adaptive to human needs, and respectful to nature. It is important to allow the humans to understand easily how the building works in order to establish a good interaction. As humans, we should adapt more active and friendly attitude toward the architecture we live and work in. So this is kind of my perception, and of course is my point of view of what we are doing and seeking and how we can keep following. Saying that, well, this is what we said. Saying that, I want to welcome our speakers, and great people coming to visit us. On this occasion, we have the pleasure to have the architect Stefan Behnisch. We are sorry that Anna Mercadé couldn't make it to come. There was a flight strike in Germany. And then we will have as a counterpoint Lara Pellegrini. Stefan Behnisch was born in 1957. He wanted to be a journalist, but did philosophy and economic science, as I told you. After philosophy, he studied architecture. It was written in his biography that he had to be an architect. His whole life has been revolved around the discipline, and all their family travels have been guided by curiosity and interest in architecture. His father, Gunther Behnisch, together with engineer Fay Otto, realized one of the most emblematic works in the history of architecture, the Olympic Stadium in Munich, in the 1967-72. Behnisch Architect was founded in Stuttgart in the 1989 in relation with his father's company. After 2 years, it became independent under Stefan management. In the following years, it opened offices in various German cities and the United States, each with a partner and a total of about 140 employees, including architects, designers, and technical specialists. His interest in architecture came from the more philosophical and humanistic side, not only the design itself. He was interested in architecture integrated in our life, especially in the integration of the social, economic, and humanistic in his designs. Stefan has directed the design of dynamic, award-winning buildings that promote sustainability within the building environment, with a design portfolio that includes master planning, public buildings, healthcare clinics, sport facilities, redevelopment, offices, schools, and museums. He strives to design inclusive buildings that provide maximum benefits to all users. His innovative approach to sustainable architecture is highly acknowledged in Europe, North America, and all over the world, and his buildings have been honored by prestigious institutions. We have Lara Pellegrini. She's mastered in civil engineering with expertise in structural design and numerical simulation of several bridges and iconic buildings. General Manager and Business Development Director in the European territory, responsible for business development with public and private sectors clients in Spain and for operation and business growth. We know that she's now working in very big projects also in Arabia Saudi, some of the projects that you have seen during these lectures. Currently, she's General Manager for Cities and Building for Socotec Spain, former BAC Engineering Consultancy Group. As a specialist in structural design by the FEM method at BOMA, structural consultant, she worked on several high-profile buildings such as Akbar Tower, which you know, designed by Jean Nouvel, the Forum Building, also, designed by Herzog and de Meuron, the Yacuna Tower by TAC Arquitectes, the Mi Barcelona designed by Dominic Pirol, and the Superior Tower of designed by Richard Roger. So we have two masters coming today to visit us. So I hope you enjoy the talk and that you can have your questions afterwards. Yes, we will discuss. So welcome, Stefan. You can come to see us. Thanks.
Thank you very
Thank
much.
you very much.
Thank you very much for the introduction. I was giving the topic in your series to talk about architecture and technique, and I would like to broaden that a little bit. I would like to talk about interdisciplinary working in this context. You already rose the issue about our environmental problems. We all know that the built environment is one of the largest problems we have when it comes to sustainability, to energy waste, to environmental impact. Now, as you see, it's nothing new. Since 1824, we know that there is an environmental impact with human-caused CO2 emissions. So, pretty much 200 years now. And as you see in this list, it took us 200 years almost to acknowledge the problem and to understand that we have a problem, let alone finding any solutions for it. We are just at the beginning to find these solutions. And as we also know, politicians are in a very short election cycle of 4 years, so they are not really willing to address the issues, because nobody wants to tell the public, we have a problem, we have to change, it's going to cost us money, and it's going to change our comfort, and it's going to change our wealth. Nobody wants to do that. And we experience that very much in all the countries right now, which sort of explains a very strong move to neoconservatism. Let's keep the beautiful 50s alive. It's really a problem we face. Let me go on that. And in 1925, Mahatma Gandhi named the 7 sins of modern society. Very interesting. And except the last one, religion without sacrifice, I don't buy into that. Not in our modern open societies. All of these 7 sins, or 6 of these 7 sins, still apply very strongly. Let me explain briefly. Germany is a very good example. Politics without principles. Germany is the only country without a speed limit. And it's politically absolutely not possible to get a speed limit in Germany. It's like gun regulations in the United States. Not possible. Freedom. Totally wacky. Next thing, wealth without work, self-explaining. Pleasure without conscience. We know that we heard about Burning Man, an old hippie festival, which now is that. And one of the 10 principles of Burning Man is leaving no trace. Doesn't really work anymore. Business without morals. 2008, 16th of November 2008. Rex Tillerson, famous in the meantime, actually said in an interview, green is for sissies. And then, yeah, we know that. Science without humanity. And there are some more examples. Now, this explains, I think, a little bit why it's so difficult for all of us to address an issue we all know is a very pressing and very prominent issue. Let me briefly talk about architecture, about relevant aspects of architecture in the course of, let's say, the last century. We architects, up until just recently, more or less, focused on the elements of classical architecture. The urban, the public realm, the cultural aspects. We should never forget that architecture is a very, very prominent human artifact. It defines us time, location, and history. When you think about any man-made place, let's talk about Rome, let's talk about Paris, Istanbul, Barcelona, whatever, New York, Chicago, you always in your mind see architecture. Always. The public realm. That defines history. And it also defines the cultural ability of a society, which often doesn't speak for our societies right now. Yeah? What was a society able to create? So, public realm, cultural, the color, and the texture of architecture. These were the basics of architecture architects worked with. We developed further since, let's say, the last 40, 50 years. We think also about architecture in context with nature, air, climate, daylight, artificial lighting. And today, we even develop further. We think about material responsibility, the reuse of materials, about the materiality, about the qualitative aspects, noise, about flexibility, reuse of buildings. How can we create less waste? How can we use the buildings longer and better? And then about using the existing building stock, urban mining, reusing of buildings, reuse of materials, and then also how can we produce in the buildings our own energy? How can we get them ideally off the grid? And that is suddenly, architects are depending more and more on the interaction, iterative process with engineers, the interdisciplinary working. It's becoming more complex, and we depend on more and more on outside knowledge to help us develop that. Building technology, interdisciplinary design, that was something we did for the IIT campus in Chicago. They asked us, what could be the building of the future, the independent building of the future, off the grid, using only existing materials. And now, this is just an example. If you don't have content in architecture, if you don't have to look into structure, sustainability, usability, whatever, it becomes very formal and superficial. It's fun, but suddenly you can make it a boat, you can make it a ship, you can make it advertisement. And that's probably for nowadays a little bit too lame. We work very closely with engineers in architecture. From the outset, from the beginning, already in the competition, we work together with our engineers from structure, sometimes urban specialists, sustainability, energy, climate, landscape, whatever. So it's a process in the beginning, and it's not, and lighting design, and it's not something we design, then give it to the engineers and say, make it work. It is a process from the beginning, a very interactive, interdisciplinary process, and for that you need good engineers. Here's an example of, was fun. We worked here with Transola and Neil Thomas from Atelier 1 in Britain. We worked on big umbrellas. A client wanted in the desert an off-the-grid open park with cooler temperatures and exhibition halls below ground. And we found out even in the desert, 7 meters below ground, you have a very stable temperature of roughly 17 to 20 degrees, no matter what, day and night, 24/7 throughout the year. It works quite well. And we were able to develop these big umbrellas that cool down the air. It was fun, obviously never built. Let me talk briefly about the interactive process with structural engineers. Structure, like architecture, developed over the centuries. These very old in Mykenae, they weren't able to really build the arch or anything. It was very heavy structural. If we go further, 120 after Christ, they suddenly were able to express architecture already structurally. They could decide, I want to make the bow, the arch, or I may want to make it flat. They suddenly could play with the structure. If we go further, structure became a very, very prominent element in architecture. It expressed the architecture, Eiffel Tower, Crystal Palace. There was a new aspect in architecture that dominated the appearance of buildings of architecture. It made it very prominent. And it's always been in architecture that way. Until we mastered a subject, it became the dominant element in the architecture. And then once the subject was mastered, it played its role and something new became dominant in architecture. Here, also a different way of structure. Structure as a cultural element. And now I want to talk briefly about a building my father did with the engineers of Jörg Schleich and Frei Otto. The facilities for the Olympics in Munich. I'm showing this because this was right at the brink of something new, very new. It was when the computer started becoming an element in architecture. They had won the competition, and for a very long time, the state, the clients didn't know if they wanted to build the roof. And they did different studies with different engineers and architects for alternative roofs. When they did the competition, and this is a competition drawing, the roof was never important for the architects. It was about the landscape, the Olympic facilities in the landscape, and pretty much to the end of the competition, the story says, they said, we need a roof. We want open. They looked at Earth stadia at amphitheaters. In Poland, there were these earth stadia. They looked at that and said, that's what we want. And then they say, yeah, but it rains occasionally, we need a roof. And they used stockings in the model and just had this tent roof. Didn't know how it worked. And then it took a while, and just 3 years before the Olympic Games, they decided to build the roof. And the roof, here are the chain models, or the physical model, test models by Frei Otto. And some of the facilities were calculated by Frei Otto with these models, chain models, and some were calculated by Leonard and Andre already with computers. They had a company in Stuttgart at the university, someone write programs, computer programs for that, which were later used by Lockheed or McDonnell Douglas for airplanes. And the challenge was, if you look at it, they had to build the tent at the ground. The net was built at the ground. They had to measure over 1 million knots by the millimeter, that when the tent is pulled up, every knot is at the right place, and you don't have overtension in any place. So it was really amazing what they did in this very short time, and it worked. They couldn't over-engineer it, only by a little margin, because it would have gotten too heavy if they over-engineered it. They couldn't under-engineer it, obviously. They had no experience whatsoever and had less than 3 years to do it. And they managed to do it. Just thinking about it, right now, to build an airport in Germany takes 12 years or something like that. And they were able to do that in 3 years. That's pretty amazing. So, but that was a very close working relationship between architect, structural engineers, and very good clients. There were 3 politicians from 3 different. There was Franz Josef Strauß, very conservative. Bernhard Vogel, SPD, socialist, the mayor, and Willy Brandt, social democrat, chancellor. And these 3 said, okay, we dare it, we'll do it. We make this decision. Politicians who were willing to take the risk. And it worked. It was worth it. Let me talk about other structural approaches. This was a competition we did in my father's office, and it was the first project when we opened our own office. We were able to take it. It was never built. But the theory was, at the time, structurally, we understand complexity, complex issues. We don't need to express the structure in a high-rise building anymore. You all know probably by Foster, the Hong Kong Shanghai Bank. That was for us sort of the end of high-tech architecture. You can't go further than that. So why can't we do a high-rise building that is dancing on a foot or on a toe? Playing with the structure. So we designed that. We won the competition, started working on it, then it was stopped. The next one was even wackier in a way. The National Archives in Copenhagen. You don't see the size of the building, but the archives alone were more than 90,000 square meters. It's a huge building, huge. And we won the competition, we designed it. We had the structure, a steel structure already in place. And then they stopped it. Elections, very conservative government, and they stopped all foreign projects of foreigners. Boom, zack. And then, finally, we were able to build it. Interestingly, though, we won the competition with a rather almost lame block without this high-rise part, just a block. We won that competition, and then we were lucky after reunification in Germany. They wanted, this bank, Norddeutsche Landesbank, wanted to merge with the Berlin bank, but the Berlin bank went under in a scandal, so they couldn't merge. So they needed more space. And they asked us if we could add another floor, and we said, nah, we can't really do that urbanistically. But we have the idea of a high-rise building there. And they asked how much will it cost? We calculated something. They said, okay, we'll go for it. This high-rise building was very challenging in a way, but it follows a different orientation of the city. This is the post-war city block, and this is oriented to the old city part, which is less organized. And this structurally, I'll come to that. The building itself is very sustainable in a way, technically. It has geothermal wells, not very deep. And because they have built the subway next to it in the 60s, the groundwater table can't move. It's caught there. So we have a huge seasonal storage under the building, which we heat up in summer and cool down in winter, counterbalance it. That covers 70% of the heating and cooling energy, but cooling is only the tower. Here is no cooling. It's all natural ventilation through chimneys. It's a very low energy building for that time. Today we could do better. With natural ventilation, with a double facade here. These are the chimneys of the floors. They are located here. But let me get back to the structure because that's interesting. The building is structurally a concrete composite structure, high density concrete. And since it cantilevers so far, it has these shear walls pulling it back. Here you see that, the shear walls pulling it back. What is interesting, the whole thing is balancing on these two columns here. And the structural engineers always told us, you need a little bit more weight in the back, you need to add a little bit floor in the back or in the bottom. It's really balanced. And these two columns, here you see them, here you see them, they need a stable temperature because it's cantilevering so far that even if they only extend by 4 or 5 centimeters, the pans would roll off the tables in the high-rise building. So it's a very stable temperature element in there, so they can't extend, shouldn't extend. Here you see that, and here you see how they say, oh, we need more weight back here, or we need a little bit front here. Now I'm going away from structure, I'm going to another aspect. This is the Genzyme headquarters in Cambridge, Massachusetts. We have worked here with Borough Happold on this building. And the building is a low energy building, comparable. But it doesn't really matter how much energy it uses, because this is a power plant, and we were able to use the cooling circle of the power plant that normally just dumps the heat in the water, to use the cooling circle of the power plant to heat and cool the building with absorption chillers. So it's a net zero building, to be honest, because instead of heating up the river, we heat up the building. That's the only difference. So that's an aspect that is very important. Where is the building? What is nearby? We have done something similar in Bavaria with a city hall, when close by is a laundry, a commercial laundry that creates a lot of hot water. And we can use the hot water to cool and heat the city hall instead of bringing it in the rivers. That's the building, and the building itself, because it's such a deep floor plate, has a natural daylight enhancement system. We have 7 heliostats on the roof that catch the light and reflect it in the depth of the building. The quality of daylight, though, is the change. It's not because it's daylight. You can artificially reach the same quality of light almost as daylight. But the change, the cloud, the trees, the colors changed. And once you reflect daylight with heliostats, it's canned light. It's static. It's not change anymore. And so we developed these chandeliers here in the mid that turn in the air return of the atrium, change the light sensation in the building. So suddenly you have the feeling of the daylight again. Another project also done with engineers, with friends of ours, very interesting. It was a competition, we didn't win. They wanted in Dublin, it's in Dublin, a drawbridge. Now everybody thinks drawbridge like that. We said, nah, it's not really good. It's a lot of power you need, a lot of strength. You have to over-engineer it to just pull it up. How can we let it dance, the bridge, to the side, move without effort, like a dance? And so we developed a bridge that turns to the side, dances to the side, and also balances by dipping these counterweights in the water, balances it out with the water. You see it here. And that was, it's old, it's a crude, it's not rendered. But the idea was, can we move a bridge without the power and the effort? It should actually work with a push of the finger to move it and not have these powerful things. We didn't win though. They didn't believe us, I think. But it was fun to do, very good engineers. Another one. Now I'm talking briefly about wood, the qualities of wood in architecture. This is the conference hall of the World Intellectual Property Organization. It's a United Nations organization for the protection of brands and intellectual property. We did this administration building for them and this one. And when we started we were in the midst of designing that, 9/11 happened. And suddenly bomb blast became an issue also there. How can you do that? That's why this wall is here. We decided to do a wooden structure here. It's a conference hall for 1,000 people. We decided to do a wooden structure for various reasons. One reason is we had just finished a parking garage below the building when they decided they needed a conference hall. So weight was a big issue. We wanted to do a very sustainable building, so wood from the area, not more than 100 kilometers, was an issue. Third, a conference hall is usually used at a maximum of once a week there in this sense. So you don't want a building mass. What you want is a climate that slides. That means it cools out, it heats up, it doesn't matter, because right before you have a meeting, you can easily heat it up or cool it down, and you don't have a big building mass to carry the weight, to pull along. So wood is ideal because it's light, it doesn't have building mass. And the last aspect is wood is structurally far better than any other building material we have. The hall itself is for 1,000 people. It's a free span. And here in the say, it cantilevers 40 meters. No other material we could have done that without a huge effort. And here with the wood, it wasn't a problem because we created a closed box. What you see here, the open elements, we blow the air through for the air conditioning, so it's always dry, kept dry. And this is a free cantilever over here. You don't see it here in the section, there's a concrete column here that holds it, and then it cantilevers free. And another huge advantage of wood is bomb blast. It's far better than steel, glass, or brick, or concrete, or anything, because it's elastic. This building, it's also cooled with seawater, with the lake water. Lake Geneva is very deep. It has low temperatures in the bottom, so there is a water tube going there, and it's a full CLT structure with only steel joints. It was partly prefabricated and brought there. So everything, the structure, the interior, everything is wood here on this building. What you see here, these Sputniks, we designed these, we designed the tables, we designed the chairs, we designed these elements. You know, in conference halls, usually the ceiling is cluttered with loudspeakers and all this kind of stuff. And this is all hidden in there. They are all hidden in there. You only have little cameras here and some microphones hanging. The tables and chairs we have designed because the depth of the table is a given. The depth of the seating area of the chair is a given. They move automatically. The only thing that is not a given is the depth of the structure of the chair, of the construction of the chair. And by designing new chairs, we were able to save 2 centimeters, which gave us 1 row, which are 89 seats. So just the 2 centimeters of the chair. Was a very good client and was an interesting, very interesting project. It was our first large-scale wooden structure. Now, let me talk about Harvard, where everything comes in a way together. In 2005, we won a competition in Boston for the Harvard University. It was a competitive interview. They had invited, I think, 8 architects, well-known international architects. And we had to, not to show a finalized design, but we had to analyze different sites, how would we approach that, and so on. Let me show you. Harvard had acquired this whole, that's Harvard Business School. Here is Boston, there is Cambridge. That's the classical Harvard. Stadium, Harvard Business School. And they had acquired all this to extend Harvard, to double their size. And they asked us to study a site here, a site there, and I think a site there or whatever. And to show them an approach to architect, to a possible solution for a science campus. And we worked on that. And we came to the interview. We gave an interview 1 hour for 40 jurors. It looked as full as here. And then every time they kicked 2 out. And after the 3rd interview, we were last standing. We had won the competition. That was a bit stressful, I have to say, the whole thing, but interesting. Now, they wanted a very sustainable building. They wanted a science campus at the time. And we designed it, we worked on it. We did build the basement. The basement alone is 40,000 square meters. And then 2008 came. And 2009, they put a stop to the project. And we had for 3 years to babysit the basement because it had to be kept an open construction site. And 2011, they came back to us and said, we want you to proceed, but totally new program. Completely new design. On the old structure. Was incredibly expensive because we had to change the structure below and nightmare, but very good client. And so what you see here, originally it were 4 buildings, 1, 2, 3, 4. And you see here the old cores still. Stairs, elevators, everything. Because they want to be able to expand here later on. But this alone was as big as all 4 before. So it's a major building. It's a school, SEAS, School of Engineering and Applied Sciences. It's a very broad approach to School of Engineering. When we think School of Engineering, we just think machinery, structural engineering, or whatever. Here we have medical in there, bioengineering, robot programming, clean labs, wet labs, dry labs, computing, whatever. So it's a very broad approach to engineering, very interdisciplinary approach to engineering. And that's the building. And Harvard said, we want a building that is very sustainable. Before they stopped the project, we even had test drilled for deep heat mining there. We went 4 kilometers down with a drill to see if we could produce energy if we get enough steam to produce energy. And then after 2009, sadly, they put a stop to it. It was too risky. But here's the bicycle rack, a wooden structure. The most complex bicycle rack we at least ever did. But it was interesting, and we wanted a contrast. It's part of the landscape. Here, this is the school, the teaching part. It's 3 floors. 1 below ground and 2 floors above ground. It's altogether about 60,000 square meters, the building. What they wanted is, as I said, a low energy building, a high-tech building, not low-tech, a high-tech building, but low energy and as efficient as possible. So we have different things there. It's a living building challenge was the basis. That means in all interior material, we had to check the supply chain. No poisonous materials were allowed. No materials based on poisonous construction, and so on. We're only allowed to get 15% of the materials. And this alone is LEDs, lighting, and building management system. There you have already your 15% of poisonous material used up. So living building challenge, low energy cooling, low energy heating, and daylight enhancement. And I'll come to that. I'll explain that in more length. These are the teaching labs, the maker spaces, the main atrium, which is also important for the climate system. Here you see the section, the 2 floors below ground for teaching here, 2 floors above ground for teaching, and these are the research labs. The boxes are the research labs. These are research labs. That's a computing lab. Most of the times people want these rational labs. We all know that. These very technical labs like these ones, yeah? That's what most people want. And here we had a teacher who said, why are labs always so boring? Can't they be different? And we say, sure, happy to. And so we developed these kind of labs for them. They wanted more openness. These are the robotic research labs with office spaces. Here you see regular labs, wet labs. And now I'm coming with workbenches to the living building challenge. It's probably the most rigid system. We have LEED, DGNB, BREEAM, all these systems. Most of them are okay. They give you, the advantage of these, or the merit of these systems was they gave sustainability a branding, not more. I could do a LEED Platinum building that is really an energy hog and still check all the boxes. So it's not a guarantee for sustainability. The living building challenge is more difficult because it doesn't look only in quantities, it also looks in qualities. In light, daylight, materials, water usage, there is everything in there. Far more complex than LEED, for example. The building is LEED Platinum, but also living building challenge. The energy consumption of the building was way below what we had expected at this building. The water cycles, I don't go into that, but it's It's flushing toilets, it's watering the green, the outside. It brings the water to the HVAC system and so on. So hardly any water goes in the channels. Reclaimed wood, reclaimed materials. It seems not much, but on a building that size, it's a lot. And generally, laboratory buildings are energy hogs. They are pigs. They use a lot of energy, laboratory buildings. To save in a residential building 50% of energy is great, but doesn't make that much of a difference. To save in a laboratory building 30% of the energy, it makes a huge difference. Yeah, and now let me talk briefly about the shading and daylight enhancement system. We all know that shading is a major issue in buildings nowadays, because cooling in summer uses a lot of energy. And we know, for example, 3 degrees Celsius cooler building in summer just doubles your energy. Just 3 degrees. So whatever you can do to avoid overheating is good for a building. We use a lot normally the movable blinds. The movable blinds are a good idea because you can tilt them, you can reflect daylight in. What we tend to forget is movable blinds have, let's say, an office building of 40,000 square meters has around 1,000 motors for the movable blinds. Each motor is about 60 watts. So we are talking about 60 kilowatt. That means you can't even at the same time close them or open them without the whole electricity failing in the building. So we tend to underestimate the complexity of it, not talking about breaking, repairing, fixing, and so on. So we said we want a sun shading system that is fixed, but is intelligent enough that it reflects the daylight in the depth of the building, keeps the summer light out, but lets the winter sun in. And in each direction, it's a different approach. So we designed that together with our engineers from Bartenbach Lichtlabor and Transolar. We designed that and optimized it. And the next challenge is you want it in a way that you still can look out, the visibility to the outside, because the blinds, the movable blinds down usually lock out your view to the outside. So we wanted to keep the view to the outside, not disturb too much. And as I said, reflect the daylight in. And very important, contrast is very important. That means when you look out, you don't want bright and dark next to each other. We all know that when we look in summer through the window outside and have a closed door, a closed wall left and right, it's very bright. So the contrast is important. How can we minimize contrast? So we worked on that in many different ways. We approached it. First, we had folded metal elements. And then we noticed when we went through it, did the construction documents, we had 14,000 of these elements. So we couldn't do them by hand. We could, but it's not fair. So how could we approach that? So we have, depending the site of the building, direction of the building, And depending how open we want it, because in where you look out, we wanted to open it up. So, but you can scale it. If you open it up, you have to make it deeper. Yeah, so it's scalable. And architecturally, we wanted it also to be pleasing. I mean, why not? So we worked on that. And we found a company, a small company near Stuttgart, that do water forming. We looked at machinery, at car bodies, for example, and looked how could we produce that. And then we found this, and we can, I don't know the English word, pressing it in depth, like carrosserie. And then we noticed if we water form it, first of all, the forms are cheaper, but we only need 1/3 of the material. Classical pressing, 2/3, triple the material from this water forming process, which is weight, which is material, which is a lot of things. So, because it's stainless steel, we had to be careful with the material. And this is the production process. And we optimized it in a way that we needed only 4 different forms, and the rest is done with laser cutting. And this is the result, how you can look out. And it works very well with the sun shading. It's funny, or interesting. It is not a complex device, but it's a very complex designed device, engineered device. The device itself is harmless, but the engineering was very complex and it works very well. So, as you see, nowadays, if we want to address our challenges, buildings don't need to become very high-tech, but what they need to be is very high-tech designed, very knowledgeable designed. They are more complex in design, but if we do it right, less complex technically. Thank you very much for your attention.
Hi, good evening. Good afternoon to everybody. And for me, it's really a pleasure to be here with you. And I want to express my gratitude to the organization to give me the opportunity to still there and to put a little bit of piece of in your education. So. We are Socotec, very briefly. We are a larger firm of engineering, and you are the global number of the company. Here in Spain, we are organized basically in 4 pillars: buildings and cities, energies, quality control, and infrastructures. In the building division that I am leading, was founded more than 40 years ago, and since then it has been growing in size and services. Was founded in the late 70s, and at the moment we are more than 100 engineers and architects. Located basically in Barcelona, Zaragoza, and Madrid, and that are our Spanish branches. In my 15, 20 minutes, I would like to emphasize how beautiful our profession becomes, joining always architecture and engineer. And because my background is the civil engineer, but I have always worked hand by hand with architects. So I really enjoy my work, especially for this communication between architectural and engineering. So 40 years ago, the building division was focused in the in structural design, and was led by architects. So let me speak just a moment for August. There is a problem here. I think that there is a problem. There is not signer here. Okay. Let me remember Agustino Viol, that was one of the founders of the company, and it was the best teacher that I could ever have had. He recently passed away, and Agustino was an architect that loves design structures. So, of course, you know, the calculation of the structures is absolutely necessary, but it's not always so exciting. And on the other hand, design structures, it's for an engineer, for an architect, much more stimulating and enjoyable. Following this philosophy, Agustí used to emphasize that as structural consultants, we were not just mere calculators. And we will try to use honestly the technology and the high tech, not only to give a static results in our projects, but also we try to assist our clients constantly in design better and better and better. So we used to say that 40 years ago, 30 years ago, we created a new trend and we generate a demand that where didn't exist before. And thank you to this philosophy, we had the possibility and to assist architectures, firms from all around Europe, the most famous architects, in a really amazing projects to support them in design. And so we had the chance to change really the skyline of Barcelona. So let me share with you some example of our works. This is, I'm sure that you know the most of these buildings. This is the Hotel Arts in Barcelona. We work here with Som and Frangheri. This is the market, Santa Catalina Market in the center of Barcelona by Miralles y Benedetta Tagliabue. This is the Akbar Tower. I personally worked 3 years in this project, hand by hand with the Jean Nouvel Atelier. It was a really, really amazing work personally for me, designing all the windows and to understand the best position of the window, of the lights. So it was really, really amazing. This is a work that we did for Richard Rogers, the Xperia Tower, also an amazing building. That was one other crazy building and experience for our teams in Barcelona, the forum with Herzog de Meuron. This lab was 36 meters, so yeah, it was really an important engineering and architectural collaborations between the architecture and the engineering. So it's hand by hand, day by day, today, arriving to the optimal structures. This is another hotel here in Barcelona with Dominique Perron. And the Joystick City in with this project was in collaboration with David Chipperfield, and another hotel here in Barcelona with Luis Mateo, another office. Offices in with David Chipperfield, several buildings in the downtown diagonals, and this is another amazing project here in Barcelona, the Mediatic office that was built top down, was a really nice experience for us with high sustainability. Then we did a lot of projects in heritage and refurbishment. So as you can see, we pass a lot of funny in our work during from the Olympic Games to these projects are from the Olympic Games to 2005, more or less. We did also several footbridges, and this is a project that we have at the moment under constructions in Malta with Zaha Hadid. So now we have a new challenges. In the last 30 years, things are changing a lot, and we need to face all together, architects and engineering. We need to face the challenge of the transition in the energy. So now we are trying to approach every project with an holistic way. But 30 years ago, there was the high tech was there was a material and there was a geometry. So the material were more or less the same, steel or concrete, and we worked over the geometries. But nowadays we need to approach the project in a really holistic way with all the specialties in engineering specialties. So as structures now become a visual and acoustic thermal protagonist of all our projects. So you know that we have big problems. The problems that we have is it's very strong. The building, you know that the building environment is the responsible of about 42% of the annual global emission. It's really a lot. And the building environment, the building operation, it's around 27%. and the rest is the embodied carbon. So we need to be very conscious of that. We are trying to apply the high-tech technicals and in every day to try to reduce the CO2 emissions. So how we are acting? The engineering solutions to reduce the emissions are in the building operations are to try to attack the project in the form more holistic possible, with a sustainable approach, of course, and with seeking for the energy efficiency and the low impact solutions. We do bioclimatic design and dynamic energy modeling. Of course, water and energy consultancies. We have softwares, very powerful software to for the embodied carbon and life cycle assessment. We did the facade optimizations, the light and solar studies, computational fluid dynamics, and outdoor thermal comfort, and we try to applicate the modern method of construction as we can. And of course, we calculate the life cycle cost of every building that we are designing. To reduce the embodied carbon, the only way it's try to not consume and to reuse. So we are designing for the longevity, for maximize resources and avoid waste. Try to make the buildings adaptable and flexible, and designed our building to be disassembled. So this is an example that we are working now in this building. It's in Madrid. The architects are Hedderwick Studio and CLK Architects. It's a really challenging work for us. We are implementing the concept of low impacts and circularity, and we are trying to arrive to zero carbon design. We start from the choice of the material. Finally, we use CLT woods everywhere, and the cement of the concrete is low in clinker. And we use a lot the design based on MMC. So for the easy maintenance and the possibility to be in a removable building in the futures. So that are some croquis about this building, and here you are more example of other two projects. This is finished. This is in the metro headquarters in Madrid. And it is another project under construction in Rwanda. So I will try to resume in this trilemma the problem that I think that we have. I think that we resume a little bit of what Stefan has explained at the beginning of his presentations, that we often have three poles that stress the whale to solve our problems. So on one side we have the economical needs, political needs, and the society needs that want one thing, and good clients, bad clients, as Stefan said, of course, when the client it's a good client, it's always easier. On the other pole, we have the restriction of the environment, the soil, the resources, and the ecological movements. And on the other side, we have the science and the technology that are always positive in general. So at each extremes, I think that the attitudes are not really sustainable. So the sustainability, I think that it's a trinomial of it's in the middle, because if you go more in at political problems, the way to go ahead, it's business as usual. The increasing economy. Then we have the growth philosophy of the ecological movements, and then we have the I write here technical optimists, because the technology is yes, we can resolve everything with the technology, but I think that if we can try to arrive to a good equilibrium, of course the politicians need to help us. We arrive to at the new movement, like the circular economy, so reduce, reuse, recycle, and remanufactures. And we need to be aware the resources, of course, are limited, and the world is not infinite, the energy of the world. So we need to be aware that the resources are limited. And of course, to use the technology that will help us to arrive to a good, especially in the materials, in our issues. I think that the technology of the materials will play a role really important in the near future. So I would like to finish this chat with 2 sentences that I like a lot. The first one is from Albert Einstein: "We cannot solve your problems with the same thinking we used when we created them." Yes, of course, we make mistakes in the last 50 years, and we know what kind of mistakes, so I'm sure that we need to resolve the problems with new ideas and new knowledge. And the other sentence that I love is from Jean Monnet, the father of Europe, that people only accept change when they are faced with necessity, and only recognize necessity when the crisis is upon them. So we are in these situations. The good things, and luckily, all the years that we have spent wasting energy, we have created a lot of knowledge. And so, of course, 50 or 80 years ago, wouldn't have been incapable to solve these problems. But now technique and high tech and low tech and the technology will play a fundamental role. So of course the challenge is it's important. I think that we have a very big responsibility as player in the constructions. And so yes, all the scientists are agree that it is possible to combat the climate change. So I think that it's the key are you young people. We can help, of course, but I realize that young people, you have a lot of force and you are very dedicated to this to have a better future for your sons and your family. So yes, thank you for your attentions.
Oh, we can come with us, Stefan.
Okay.
Now it's the turn of, well, thank you both for explaining so well your vision towards architecture, towards the future and the present. We see at your projects as a future, but they have already built, so it's a present, and we are happy to acknowledge that and that you have shared it with us. And now it's the moment, questions, maybe, yeah, David Baena, professor from school, would like to join us.
Hi, Stefan and Lara. Well, first of all, I am very impressed with your works. Are very interesting, not for me, also for all the students, because it's very good that we can speak about big projects in terms of high tech and low tech. Okay, I have a question. I am very interested in your opinion about a material, concrete, not concrete. Sorry, the wood. The use the wood using in the construction buildings, in the structures, and so on. Okay, because there are from few years there is a fever in the universities, in the clients of the public clients that wants to use the wood very a lot of times, no. It's possible, or it's good to use the wood in our area, Mediterranean area, because we don't have water, we don't have a lot of forests. This is, I think that's, your opinion is very interesting for all the students, because I am teacher in the last year of the career, and a lot of students build or think your buildings, your projects in wood. I think your opinion about this excessive use of thinking about, because in our area, in the Mediterranean area, I think it's not okay.
Good. Maybe a couple of thoughts to that. As I said before, something new is always a hype. Wood is definitely not the answer for everything. I think we have to discuss, when we design buildings, the material appropriateness. What is the appropriate material for a solution? If I build a structure flexible enough that I would say it can last different purposes. Example, we did a laboratory high-rise building in Toronto, but we did test fitted for the client also with offices, even student housing. So they could reuse the same structure for many different purposes. Then probably concrete or steel is the right answer. Wood is, in big structures, often not the right answer. We did studies, the CO2 impact of wood, and we found out that a wood-steel hybrid structure is far better than a pure wood structure for very simple reasons. You build less high, you save facade. The floor-to-floor ceiling height is 40 centimeters less. Mm-hmm. Then the footprint of the columns is a quarter in steel, less than a quarter. That means you build less. So if you calculate all this through, you suddenly notice a pure CLT structure with wooden columns and beams is often not the right solution. Often it's a steel wood hybrid structure is the right solution. You could go even further. I saw your list, interesting list, but there was the top point missing. Don't destroy buildings you can reuse. Yeah? That means we often demolish buildings, old concrete buildings, and rebuild the same stupid structure again at the same location. Why don't we reuse the concrete? And suddenly the appropriateness of the material becomes a different discussion. We cannot afford to build everything in wood. And wood had also one last point, one huge disadvantage, especially in your climate: no thermal massing. That means you need to add thermal mass, and suddenly you're at a wood-concrete hybrid structure. Or at least you need a wood geothermal structure, geothermal with active ceilings, clay ceilings or something. It becomes more complex. So the answer is more complex than just simple wood.
And I completely agree with Stefan, and I only want to add that it's not a problem of Spain. In Spain there is a lot of wood. The problem is that we are not working well the wood and the forest. But the problem is it's all around Europe.
So, yeah, the students, Marco, or you, Felipe?
Hello. So, in preparation for this talk, I was looking at your website and reading about the circuit project, which I'm very interested in. And as a developing architect, I'm wondering, how do you incorporate high-tech solutions into designing for the circuit project or similar projects where we reuse materials or have a standard material bank to design from? And do high-tech solutions have a place in that, or as long as they're easily recyclable? Just, I guess, general advice for developing architects.
Okay, you opened a whole new discussion, but very interesting one. Let's talk about circuit for a moment. I'm not for high tech. To avoid a misunderstanding, I think there are some solutions that need to be high tech, but avoiding technology is always good. I'm more for high-tech engineering, high-tech thinking, complex engineering to reach a low-tech architecture. But let me get back to the circuit, because circular economy, because that is a very interesting topic. It sort of turns our architectural design thinking upside down. So we are used to the process: sketch design, schematic design, design development, construction documents, tender, and then building the stuff. That goes different because we don't really know what materials will be available when we are in the later phases of a building complex. That means we need to sort of plan parallel. And we have, when you looked at the project, we have developed, just out of intellectual curiosity, a grasshopper tool that tells us how the building in its appearance would change, and also the CO2 calculation embedded into that. If, for example, we get brick instead of sandstone or clay or whatever. So how can we react flexible? It's also against our building permit system and so on, but that's beside the point. It's a very, very interesting question because we need to be more flexible. We looked at this project at the Hamburg building waste plan. We know we can look up which buildings will be demolished in the next 5 years and what materials will become available, so we can plan with that in a circular economy. But the interesting thing is, everybody thinks Hamburg brick, sure, we'll have brick. We know today that in 5 years' time, there will be no more brick available from demolished buildings. So we suddenly have to rethink the whole circular question. And as I said, we need to develop tools how we deal with that, and we need to learn a more flexible approach to designing buildings. Good question.
Thank you.
My question, just to add to this one, when we think about circular construction, for how many years do you think, I mean, are you making like the calculation of nowadays for the life of a building? Or
Okay, let's look at the building stock we have right now. We have managed to ruin environmentally sound buildings in the last 70, 80 years. Before that, we didn't have a problem. But 80% of the world building stock happened in that time. And these buildings are, on the one hand, very suitable to be reused because they are developed, industrialized. That means all trades are separate, not integrated. All trades are separate. So they are very suitable for that. On the other hand, they are very shitty technically, pretty bad. Yeah, they're more or less will fall apart by themselves, most of them. The only thing that will remain is the concrete and steel structures. So we need, for this building stock, more to think about less circular, because gypsum board you can't really reuse, and they are cheap gypsum board buildings, most of them. Pretty bad buildings. Facades are single layer,
Yes.
no sun shading, no thermal break aluminum facade. So we need to think about how can we upgrade them? How can we fix them? And one thing we should always keep in mind that's very important when we discuss this. We have been focused on the building maintenance energy. That means heating, cooling, whatever. The closer we come to 100% renewable energies, the less important this aspect becomes. The more important the gray energy becomes as a focus, the embedded energy. Because in an ideal world, when we have all renewable energies, when we can produce on the roof and on the facades our energy, we probably don't even need much insulation. The material we use for insulation is probably a bigger problem than the renewable energy we use to maintain the buildings. So we have to rethink that whole thing in the course of the next 20, 30 years. But thinking about the building stock, if I would now open a new business, see, I have the advantage, I'm old, I don't have to think about that. But if I would rethink a career now, I would say, let's focus on fixing the existing building stock. I personally don't want to see any glass tower in the southern hemisphere, including Barcelona, without sun shading. It doesn't make sense anymore. It doesn't make sense. We have built buildings where we die inside the buildings if the electricity is shut off. We don't get air.
Yeah, completely.
Wrong.
Completely. Yeah, we agree. I'm also with the project of Harvard. We could see that you also manage the way that somebody can use the window. No, it's not completely.
It's operable.
You can open the window and you can ventilate and you can have the air. No, it's not. You are not in a prison. Is what happens. No, sometimes with the high buildings. Okay. Next one. Who wants to?
Question for Stefan. First of all, thank you for your presentation. And based on your examples you showed, we can clearly see that not always the unprecedented things in architecture, like you showed us the bridge example that you sadly did not win, that always the community didn't always understands what you're trying to deliver. So question is, how do you engage with the community and local stakeholders to ensure and tell them that the sustainability designs align with their needs and values?
Okay, first of all, my hybris and ego is not so well developed that every time they don't choose me, I think they are wrong. Okay, sometimes they have a good reason for that. That's one point. The other point, yes, it's a double-sided sword. Often we architects have the very simple excuse, oh, the client didn't want it. And often it's a very lame excuse. You can't force clients to do something, but you can nudge them. And you can push them. And you have, I'm very sorry, but you have to educate your clients. You have to have a story. If you have a design, you need a good story to tell, to explain it. When I taught students, I always said, you need the one-liner and half a page. If you have a good design, it should be shown in a very one-liner sketch. Okay, three-liner sketch, who cares? And half a A4 page. If you can't explain it in that half a page and this line, your design is too complex. Nobody will get it. Clients won't get it. And you have to, I always in the office when I discuss with the architects, what's the story? Can I tell a story about it? People, most of your clients are not architects, are not architecturally educated. They like it or they don't like it. And if you're depending on liking or not liking, you're lost. That means you need to be able to tell the story and lead them to the solution. And in the end, do you want to really be responsible that this ice bear drowns? That's the bottom line. And you have to bring the story to there to explain to them. Nobody wants to be a bad person. Most people are too lazy to be good people, but nobody wants to be a bad person. So you have to tell the story and try to explain the civil responsibility. You can't force them. You only can hope they understand your thinking.
Do you hear me? Yeah. First of all, I would also like to thank you for this amazing presentation, both of you. My question would be mostly about prioritizing aesthetic innovation and functional efficiency. How do you approach the challenge of ensuring that high-tech buildings remain relevant and adaptable throughout the time, and particularly in the context of rapid technological advancements? Because everything develops really fast and we need to adapt to it. How do you say it? Thank you.
Can you repeat that a little bit slower? I couldn't follow.
Sorry.
My hearing isn't as good as it used to be.
Yeah, so prioritizing aesthetic innovation and functional efficiency, how do you approach the challenge of ensuring that high-tech buildings remain relevant and adaptable over time, particularly in the context of rapid technological advancements?
Okay. High tech is per definition and per se not very adaptable, to be honest. The technical HVAC buildings and so on. As I said before, all technique you can avoid is good and helps you with these buildings, also in flexibility. And it always depends the climate and the situation. But generally, for example, if we do a climatized building, if we have to do a climatized building, we try to go for geothermal, slab heating, active slab, or decentralized facade heat exchangers like fan coil units, because they are easily to be changed, taken out, new ones in, to be adapted. If you have central air cooling and heating, first of all, you have huge channels, a huge building volume extra. You have a hygienic problem with these, a high maintenance problem with these, and they are almost outdated once you have the building finished. Yeah? If you think about it, up to 40 years ago, 30 years ago, they have built air ducts of asbestos, which was not a very good idea. Eternit air ducts, not a very good idea. And not all of them have been ripped out by now. So try to be, and also to move temperature with water, you need a tube like that. With air, which is the best insulation material except vacuum we have on this planet, instead of that, you need that. Yeah? So think about efficiency, and think about, when you think about comfort, the human body. What do you really need for comfort? Your temperature feeling is the head, for example, coolness. So radiant cooling is far more efficient than cooling down the air. Your comfort, where you don't feel comfortable, draft, for example, air draft, is your feet here. That's where you feel uncomfortable. So you really have to think about the comfort feeling of the human body. And if you do that perfect, for a jacket, taking off your jacket in an office environment is 3 degrees Celsius. So think about that, and then if you do that correctly, you can avoid a lot of technical equipment.
See, my question would be, because also I'm teaching at the last year course, and we are now implementing all the areas that we call is structure, technology of the installations and all that stuff. And we are trying to implement the kind of the new technology, but we are not sure. No, as we know, when you are trying to be innovative, as you are, of course you need to be guided by good engineers, that allows you to understand why this new technology will work well, in a building that you are doing new. So as a of course, we are in a Mediterranean area, no? The climate is quite different from the one in Germany, but maybe better, similar than America. Which will be radiation, I understand perfectly, it's the best way to heat and cool, but which system will you recommend for big surface, no? Like industrial buildings?
Office buildings, for example.
Or office building, let's say.
I would recommend radiant temperature and natural air.
Circle.
Yeah. For example, the Gensheim building, the air return is the atrium, but often we use, like the Nord-LB I showed, the one, we have chimneys for the air return, and we bring the fresh air through the facade. And sometimes in cold climate, we preheat it.
Okay.
And in the air return, we have a heat exchanger. But decentral is always better than central, always.
So you use the facade as a buffer, no? Like to make this intermediate space, no? From exterior and interior.
The air streams through, we have flaps in the facade, through the facade. It gets preconditioned, active or passive, depends, and then goes through a noise damper in the dropped ceiling in the hallway, and from there in the chimneys to be sucked out by 2/3 of the year natural stack effect, and 1/3 we need a vent and heat exchanger. But it's a very low tech, very simple way to deal with that problem.
Yeah. So with the air, no, the quality of the air, when it's heat or cold, no, it moves differently, and then
and the cooling and heating go through radiant.
Radiant. That's what I want to ask. Thank you. Yes.
Hello? Yeah. I'd rather think personally that building, no, needs somehow an optimistic point of view. Otherwise, you just don't work. You just don't build. No. But saying that, Lara, you show a triangle, no, that was pointed out of optimistical point of view through technology is something that is from the past. But anyway, the optimistical point of view through technology, contemporary one, should be necessary. Otherwise, we'll start to build, or not to build, or build with things from the past. So what I wondered, you said that, of course, technological point of view, it's not something that you put on a building. No, it's a way, previous thinking, and nowadays we have tools. So I would like to speak a little bit about of this kind of optimistical way of looking at technology from nowadays.
Yes, I think that we have a lot of to do in materials, in new materials. I think that all the scientists dedicated to the technology of the materials are working because we have a lot of elements. There are elements that we're using more and elements we are using less. So perhaps we are able to discover. I think that there is a lot of I+D research in this field to use material that we haven't used before. So and of course to reutilize all the materials that we need to give the materials new lives. So I think that we need to be positive, and there is in our project, we are able to reduce a lot of the CO2 emissions, arriving sometimes to a zero emissions. So it is possible. We only need the help of the governments, of the politicians, because it's really difficult in the environment that we have. And of course, the project but paid from the administrations, and but the technology exists. What do you think,
Okay.
Stefan? You don't agree with me?
Oh, partly. I'm a little bit careful with this optimism because the public opinion and the politics always jump on. We have the discussion right now in Germany. Oh, we don't need to get rid of the combustion engine because we'll have e-fuels in the future. We will have nuclear fusion in the future. Come on, get real. Yeah, and that's a little bit why I'm not all around that optimistic. I think I'm optimistic we'll find solutions, but now we need to work with the solutions we have. Yeah, we need to work with wind, photovoltaics, water, whatever. We need to work with what we have. We cannot use the optimism of a future to remain with old solutions because it will be solved technically in the future. We cannot afford to do that. We need to act now. And I do agree, there is reason for optimism that we find solutions, but we need to be in one point very realistic. Right now, we have maybe 20% of the problem solved, not more. We don't know much yet. The building sector is still a huge problem. And until we are at 100% in renewables, it will remain to be a problem because there is a shortage in housing. We all use more and more space personally, and so on. And I'm not only talking about Central Europe right now. I'm not talking about Africa or any other country. So, yes, there is hope and there is some optimism, but we need to act with what we know now and have now. Sorry.
No, I'm agree with your point. I think that nowadays we are doing the things better than 20 years ago, for example. So I think that and without talking about the increasing of the population in the world, so we have a very big, a very huge problem. So, but yes. We need to see the future, doing the things better and better and better, and find, of course, a new form of energies and to apply to our buildings.
For example, now we have the tools to know what's the temperature and the sun that is going to be in 3 days' time. And we are able to fix our systems in order to fit that knowledge. Or we can calculate a beam just with the material that is needed, because we have simulation programs and so on to adjust deeply what we have to do. So what we have is much more powerful tools to reach what we need to reach that we have about 10 years ago, 15 years ago. And that makes I think we are just starting. A lot of things with IA and so on that will be able to feed us with our designs in order to make it properly. No?
I agree. We have the ability, but still, when you walk through our cities, they are building glass tower like 50 years or 30 years ago, without even thinking about it. That's what frustrates me. Sorry.
Yeah, next. Yes? Joao.
Good evening. Hearing all of these topics, there's a question more practical in terms of a student. Is that for us, maybe it's me that I'm a bad student, the design and the structure, the installations, and every other civil engineering related aspect of architecture is a bit separate from, each point is a bit separate from one another. So my question is, when in a practical sense, in real life, when do you call the civil engineer, or when is the civil engineer called, or when does that cooperation that you talked about begins?
At the very beginning. You need the impact of the engineers from the very beginning, right at the outset, because good engineers can help you avoiding the need for technique and technical equipment. They can help you there. And a good engineer I work with, Thomas Auer, he's called, from Transola, always says, we come in play, I'm talking about mechanical and so on, we come in play where the architecture fails. And there's something to it, yeah? And we need their input and their advice from the very outset when we put the pen to the paper.
For us also, it's super important to enter from the beginning, from the concept. Only in this way the things are well. We think in the same way, and we take the good direction. So that's absolutely necessary, especially in different buildings, special buildings, and not architecture, modular architects, but yes, of course, in every project in general, we will try to enter from the beginning.
I would like to add that question, because we are saying when you start collaborating, no? But it's nice also, have you studied your buildings 10 years after, let's say, or 5 years after, how they are performing? I mean, if the issues that you wanted to achieve you have achieved, so you can have or the knowledge of them, these buildings, to apply in the following one. No? Because
some buildings we monitor.
Yes.
How the performance is. Some buildings not, because client don't want to. Then we can only interview or so on. And it's a mixed review. Sometimes it's better. It never hits the spot. So sometimes it's better, sometimes it's worse. Right. And we had some examples where it was really, really bad until we noticed half of the equipment was never adjusted. You usually need, I would say, 2 full year circles to adjust a building minimum to make it work.
Yeah, and to make it more like efficient and to
fine-tune.
Nice.
Okay.
Well, thank you, Stefan. Thank you, Lara. One maybe last question, if I may, and then you take the word, Marta. We are in a photos from the university and full of students here with us. And I think that for the 4 photos that we had so far, the last one, then today, I feel that, of course, there's a larger awareness of the conscious of sustainability aspects and awareness of the problems that we're facing. And this is part of the landing and part of the photos goal. Today we're talking about technique, no? And I have the impression that you were talking about multidisciplinary interactions. That's why we also invited Lara and with Socotec and on the engineering field. What would you say to the students, and how would you? We come from times for the last 50 years of excessive architecture, very formal architecture, even from the university and from examples of very specific signature architecture in the world that was really maybe misleading even our students and ourselves on what were the priorities in the design. No? I have the feeling that right now the solutions for the problems that we're facing are way more complex, and they cannot afford a too simplistic design process and formal design process. What would you say to the students and to us professors, and how we should face or tackle the education of how we should teach architecture in our schools?
Huh. I'm definitely not the right person to give advice. But I would say, for me personally, let me phrase it that way. For me personally, architecture is very content-driven. It's a very important cultural asset. We agree on that. But it's contrary to a lot of things in the past, it's very content-driven. For me, elements of a building have to do something. It's a little bit about the story to tell. They have to perform in a certain way. They have to serve in a certain way. And it's a different way. If we look at the turn of last century architecture, or even your Gaudi architecture, the architectural apparatus did also something. It overplayed often the structural restraints of a building playfully. And now the architecture has to do something different. We have mastered these subjects. Now I think the architecture is developed out of cultural context, climatic context, urban context, landscape, public realm, social context. And that is what in the past was called the genius loci, the spirit of the place. And we just added some more elements. The climatic context in the past didn't play much of a role, but suddenly it's in there. And I think that is sort of the recipe or the basis to develop architecture, that all of these elements inform the architecture, and it's becoming more complex than in the past. Okay.
Yeah. Yeah. So thank you, Stefan, Lara. We finish here. Thank you, students, your presence and your picture.
Thank you very much. It's been a pleasure being here.
Yeah.
Thank you very much.
See you.